The next one is using quadratic techniques but for higher order polynomials. The first step is always to look for a GCF. That is the first step because that is the easiest step and it will reduce the degree of the polynomial. So what do we have in common? Among the numbers, the highest factor is 3, and among the variables, the highest one is a squared. And what's remaining? If I take 3a squared out, we have a to the power 6 remaining here. Remember, we are adding exponents. If I take 3a squared out from there, I have 5a cubed. So 3 plus 2 is 5. And here I have a 6 remaining. Now this is not a quadratic equation, but notice this exponent 6 is double of the exponent 3. So for all practical matters, we can treat this as a quadratic equation. We can just assume the a cube. We can assume the a cube as some sort of separate variable. Okay, we can assume the a cube is hidden in there. So this would become a cubed squared, and this would be a cube. So it is some variable squared and then the variable, some variable squared would be like x squared and the variable would be x. So if we can look at this as x squared plus 5x plus 6, if we can look at it as x squared plus 5x plus 6, put on your special goggles that will help you look at it this way. Now we can easily factorize this, right? It is x plus 3, x plus 2, right? So in the same way, in our case, the x squared is a cube, right? The x squared is a cube. And we can write it as a cube plus 3, a cube plus 2. You can do a quick check by foiling, at least the first and the last term. A cube multiplied by a cube is a to the power 6. A cube multiplied by 2 is 2a cubed, so you're going to get some a cubed term. And then 3 multiplied by 2 is 6. Okay, so see if you can imagine the a cube as an x. Now this will only work when this exponent here is double of this exponent here, because we always want this exponent to be double of that exponent. Okay, so 2 and 1. We're always looking for 2 and 1. And this one can be imagined that way, and you are done.